students. Yeah. So shall we get started? Yesterday, we discussed about simple microscope. So for simple microscope, I asked you to revise two things. What is that? The magnifying power when the final image is formed at the least distance of distinction is 1 plus d divided by f. Then what is the magnifying power when the image is formed at infinity? It is
d by f.
d by f. I hope you guys have revised it and you understood thoroughly of how these values have come, right? It is then today's class will be very easy for you to understand. Listen. So the next concept is compound microscope. So simple microscope, as the name suggests, is a single convex lens. Compound, as the name suggests, it is a combination of two lenses together, right? Where one of the lenses is called as objective and the second is called as eye lens. So some people call it as object lens and some people call it as objective. Similarly, some people call this as eye lens, or you can call it as eyepiece, T-I-E-C-E. So either of them is possible. Okay. Now listen to this carefully. The idea of compound microscope comes from the fact that we know what happens when two lenses are taken in combination. Their focal length is going to be something like this: 1 by f effective is equal to 1 by f1 plus 1 by f2. Similarly, the magnification will be multiplication of magnification produced due to each lens. I hope you guys remember this. Yes or no? Right? So in the same logic, if I use a single convex lens, then it is going to be a simple microscope. So what I will do is, we will produce magnification with one of the convex lens, and that magnified image will be used as an object for the second convex lens to produce a bigger image. Does it make sense? Right? So what are we doing? The logic is very simple. Using one of the convex lenses, you will magnify the object first. Once you magnify that object, the magnified image produced due to the first lens will be used as an object for the second lens, so that the second lens will further magnify the image that is produced due to the first lens. Right? So having this in mind, let's try to understand what actually is a compound microscope. First, basically a compound microscope is used to see extremely small objects, means it is used for seeing microorganisms or something. That is the main reason why it is used in biology labs, right? So it consists of two lenses. A lens of short aperture and short focal length facing the object is called as object lens or objective lens. As this is the one which is closer to the object, we call this as an object lens or objective lens. Similarly, you have another lens of focal length and large aperture. You have another lens of large focal length and large aperture, which is called as eye lens or eyepiece, which is also called as ocular. Okay. Now, these two lenses are placed coaxially. What do you mean by coaxially? They're going to have the same principal axis. So both of them are placed coaxially at the two ends of a tube. To focus over an object, the distance of the object lens from the object is adjusted with the help of rack and pinion arrangement. So those things I can't show it to you now. So you have something called as a rack and pinion arrangement, but with which they will adjust the position of the object lens with respect to the object. Now, when you take a small object, as this is used to see extremely small objects, when you take a small object, which is just placed outside the focus of the object lens. So try to understand one important point here. So you take this object lens, right? So with respect to that object lens, you're placing the object in such a position that magnification of that object is supposed to take place, right? So magnification has to take place. Then one of the cases where the magnification is possible is when you place it between the focus and the pole. Similarly, the second position that is possible is when you place it between the center of curvature and the focus. Now, out of these two positions, which one are we supposed to choose logically? The one that we are supposed to choose is between the focus and the center of curvature, right? So I repeated, when you place it between the focus and the center of curvature, you can say that the image is magnified and it is real. Why I need it to be real is because the object is kept on the left-hand side of the object lens, and that should form an image in between the object lens and the eyepiece, so that for the eyepiece, this image that is formed due to the first lens will start behaving like the object, and this eye lens will further magnify the image and give you the final image, right? So having these points in mind, let's try to understand how this diagram is taken. Okay. So when you place a small object, you place it just outside the focus of the object lens. So you just place it outside, means it should be between the focus and the center of curvature, where it is very much close to the focal point. Okay. Then what is going to happen? It is going to form a real inverted and magnified image on the other side of the lens, which is produced between the focus and the center of curvature, F1 to F. Right. Now, the image produced by the object the image produced by object lens acts as an object for the eyepiece. Now, what should happen is this object that is formed, so the image that is formed should be adjusted in such a way that this image falls between the focus of the eyepiece and the optical center of the eyepiece, so that this image can further be magnified. At the same time, you will get a virtual image. Okay. So I told you yesterday itself that whenever you're using any microscope, the image produced is supposed to be virtual in nature, right? So what is going to happen? The distance from the object lens is so adjusted that the final image is formed at the least distance of the distinct vision. So there are two things again. Whenever you're using any optical instrument, you will produce the image at one is training view and the second is comfortable view, which is training view when the image is formed at the least distance of distinct vision, which is comfortable view when the image is formed at infinity. Okay. So here what is going to happen is the image position with respect, so the image formed will be in such a way that the position of the image is between the focus of the eyepiece and the optical center, so that this image is further magnified. So when it is magnified, the final image is going to get formed at this point, which is A double dash and B double dash. Okay. So having said this, we will see how to derive the magnifying power of this particular microscope under the case number 1, when the image is formed at D. So let me explain this. So object is kept here. How to draw the ray diagram in exam hall? You take a ray parallel to the principal axis, then it is going to pass through the focus of the objective. Take another ray. The other ray will pass through the optical center without any deviation. Then from here, what will happen is you will have the final image. So for this final image, what you will do is you will take a ray parallel to the principal axis. It will pass something like this. And one ray through the optical center will travel without any deviation. Now what is going to happen is this ray and this ray will get diverged, so that the final image is formed at this point, and this point, this place is called as A double dash and B double dash. Okay. Now, so with the hope that this diagram is clear, I would like to label all the points. This distance U0 is the object distance with respect to objective. F naught is the focal length of the objective. UE is the object distance with respect to eyepiece, and FE is the focal length of the eyepiece. V naught is the position of the V naught is the position image position of the object. Sorry, the image distance of the object with respect to objective, and capital D stands for the least distance of distinct vision, where capital D is the location of the final image formed due to the eyepiece. Okay. So having said all these things, we know that MD is equal to beta divided by alpha, where beta is the angle subtended by the final image at the eye, and alpha is the angle subtended by the object at the eye. So if you place the object, if you look at the object here, it's very simple. So if you look at the object here, then if I take this as H naught, when you see it from the top and bottom without the help of optical instrument, then this angle is said to be alpha. Okay, this angle is said to be alpha, and this distance is going to be the least distance of distinct vision, that because that is a point at which you can see the object comfortably without the help of optical instrument. So tan alpha is equal to how much? H naught divided by D. Now what is going to happen is the final image is formed here. Concentrate. The final image is formed here. So with respect to the final image, if I take a ray like this and if I take a ray like this, then this will become beta. So what is going to be the value of tan beta? So tan beta will be equal to height of the final image, Hi, divided by the same D. This distance is D, right? So the magnifying power, we know that it is equal to beta by alpha, but beta is equal to tan beta and alpha is equal to tan alpha, right? So having this in mind, what we will do is we will write tan beta by tan alpha is equal to height of the image, that is H dash, divided by 1 minute. Yeah. So here also I can say that the magnifying power MD is equal to HI divided by H. Oh, 1 minute. I made a mistake. Sorry. Because HI is the final image formed by it. Now I can't take with respect to both the lens. Okay, I'm coming to this point. So tan beta, see, this is right. HI divided by D is right only. I'm not saying it is wrong, but I need not take that. I'll come to that point. So H dash divided by UE is also tan beta, is equal to H dash divided by UE. Right. So the magnifying power will be equal to H dash divided by UE divided by H divided by D. So H dash divided by H into D divided by E. Now for objective lens, the height of the image formed by the objective lens, that is H dash divided by H, will be equal to V naught by U naught according to the formula of magnification due to a lens. So H dash divided by H is equal to V naught divided by U naught. And if I take it and substitute it here, I get MD is equal to V naught divided by U naught into D divided by UE. But for D divided by UV, what we are going to do is we'll apply the lens formula for eyepiece. So when you apply the lens formula for eyepiece, 1 by V minus 1 by U is equal to 1 by F, where V is the image distance with respect to the eyepiece, UE is the image object distance with respect to the eyepiece, F is the focal length of the eyepiece. So VE is how much? It is minus D. UE is how much? It is minus UE only. So minus of minus will become plus. And the focal length of eyepiece is positive because it's a convex lens. So minus 1 divided by, sorry, minus 1 by D, minus 1 by D plus 1 by UE is equal to 1 by FE. Multiply with D on both the sides. Minus 1 plus D divided by UE is equal to D divided by FE. So D divided by UE will be equal to 1 plus D divided by FE. So the final magnification MD will be equal to V naught divided by U naught into 1 plus D divided by FE, and all those things will be a negative value also because the image is inverted. So it becomes negative value. So did you understand? This is the value of magnification produced due to the compound microscope. Suggest everybody to write it. So let me know once you are done copying. Done, guys?
Yes, sir.
1 second, sir.
Okay, write it. Done? Now what happens when the image is formed at infinity? You guys tell me the logic. The logic is very simple. When the image is formed at infinity, the image due to the first object should be formed exactly at the focal point of the eyepiece. So here what happened? Here it formed between the focus and the optical center, whereas here it is formed exactly at the focus, right? So H and this is H dash, so that the final image is formed at infinity, right? Now see, magnifying power at infinity is beta by alpha, which is approximately equal to tan beta by tan alpha. But what is tan beta in this case? Tan beta is equal to h dash divided by fe, because this distance is fe, the site is h dash. So h dash divided by fe divided by what is going to be value of tan alpha? Tan alpha is obviously equal to h divided by d. So when tan alpha is equal to h divided by d, then h dash divided by h into d divided by fe, right? D will go to the numerator and all those things. But we know that h dash divided by h is equal to v naught divided by u naught, according to Lenz's formula. V naught divided by u naught into d divided by fe, and this is the derivation for the magnification of image produced. There is a magnification due to a compound microscope when the image is formed at infinity. That's it. Don't worry about these things. So this alone I'll explain. The left hand side part I'll explain, but these things you need not worry about. Okay. Okay, listen to this. In general, what happens is the focal length of the objective, in reality, the focal length of the objective is less. So that's what is mentioned in the beginning of the derivation also. A short aperture and short focal length facing the object called as object lens is used. Same logic. So focal length of the objective is very small. So what we can say is V naught divided by F naught is considered to be very much greater than 1. Right. So when we say it is very much greater than 1, we can clearly say that the image formed due to the first lens is formed almost close to the eyepiece itself. Right. When that is going to be the scenario, V naught can be approximated to something called as L, where L is called as the tube length. Okay, where L is called as the length of the microscope tube, or we sometimes call it as tube length also. So what is basically tube length? Tube length is the separation that exists between the objective and the eyepiece. Okay, when that is going to be the scenario, MD is equal to V naught divided by U naught into 1 plus D divided by FE, but V naught I can take it as minus L divided. Okay, I'll make the changes. Listen. So we know that 1 by V naught minus 1 by U naught is equal to 1 by F naught according to the lens formula. So this we applied for the objective. Then V naught on both the sides, I can say 1 minus V naught divided by U naught is equal to V naught divided by F naught. So V naught divided by U naught will be equal to 1 minus V naught divided by F naught. Right. So 1 minus, we know the fact that V naught by F naught is a value very much greater than 1. 1 minus V naught by F naught can be approximated to minus V naught by F naught itself. But minus V naught means minus L divided by F naught. So what we can do is, in the place of V naught by U naught, you can replace it with minus L by F naught in the formula of MD. So if you see, MD is equal to V naught divided by U naught into 1 plus D by FE. Just take and substitute it. In the place of V naught by U naught, substitute minus L by F naught into 1 plus D divided by FE. Okay. So we'll do a problem based on it. There is a compound microscope which has a magnifying power of 30. The focal length of its eyepiece is 5 centimeter. Assuming that the final image is to be formed at the least distance of distinct vision, find the magnification produced due to the objective. So magnification due to the objective is equal to what? So the magnifying power of the telescope of the microscope is given as 30. We know that the magnifying power of eyepiece is 1 plus D divided by FE. So 1 plus, what is the value of D? 25 divided by FE is going to be 5. That is going to be 6. So MD is equal to M naught into ME. So M naught is equal to how much? MD is 30 divided by 6. It is going to be 5. So the magnification produced due to the objective in this scenario is 5. And remember, the magnification produced due to the eyepiece will be negative because it is forming a real and inverted image. Okay. The other problems, you can try them later. Now, I'll move on to the next concept, which is the astronomical telescope. Right? Telescope, what is basically a telescope? It is a device which is used to see far objects. Right? So generally, an astronomical telescope, as the name suggests, astronomy is something related to heavenly objects, right? Is used to see heavenly objects It produces a virtual and inverted image, right? As most of the astronomical bodies are round, the inverted image does not affect the observation at all. That is one important point to be noted. So here the arrangement is slightly different. Basically, an astronomical refracting telescope. So there is a refracting type telescope. An astronomical refracting type telescope consists of the same two things. One is objective and the second is called as eyepiece. But here the theory is different. The objective will be of a larger focal length and larger aperture, and eyepiece will be of a smaller aperture and smaller focal length. Reason is very simple. Greater is the aperture, greater is the amount of light that can enter through any optical device. Okay. If you see in the case of a compound microscope, since the object is very much close to the eye, except the fact that you're trying to magnify and see, eyepiece is maintained at a greater focal length, so that more amount of light is entering your eye, so that you can see the object clearly. Whereas in the case of telescope, what happens? Since the light is coming from a far away place, it is important for the device to collect large amount of light within itself. Okay. So that is the reason why, if you see, objective is going to have a greater focal length and greater aperture. Okay. So astronomical refracting telescope consists of two lenses. The lens system facing the object is again called as objective. It has a larger aperture and large focal length. The other lens system is called as eyepiece, which has a smaller aperture and short focal length. So now, how are they mounted? They are also mounted coaxially and all those things. The objective and the eyepiece are mounted coaxially in two metallic tubes. The tube holding the eyepiece can be made to slide in the tube holding the objective with the help of a rack and pinion arrangement. So it will be something like this. This can move separately, this can move separately to the rack and pinion arrangement. Okay. So logic is again simple. Why are we using two lenses? Why can't we use a single lens? Because you're going to use one of the lenses to create a real image, and that real image will act as an object for the secondary lens, and the secondary lens will produce a magnified image, right? So the objective forms the real and inverted image of the distant object in its focal plane. The position of the eyepiece is adjusted till the final image is formed at the least distance of distinct vision. In case of position of eye object is adjusted that the final image is formed at infinity, the telescope is said to be in normal arrangement. Okay, one is strained view, one is normal adjustment is comfortable view. So again, the same logic, what happens when the final image is formed at least distance of distinct vision? And the next one is what happens when the final image is formed? What happens when the final image is formed at infinity? That is a normal adjustment. Okay. So having this logic, we'll get started. So basically, for an astronomical telescope, the rays are coming from infinity. Right? So when the rays are coming from infinity, let's say the image is formed somewhere over here. Okay, that is A dash, B dash. So this A dash, B dash should be a real image with respect to the objective, and A dash, B dash should act as an object for the eyepiece, and it should be produced in such a position that is between FE and C dash in such a way that the final image due to this is produced at A double dash and B double dash, which is at a distance of least distance of distinct vision from the eyepiece. Okay, it is from the eyepiece, and A dash by B dash is approximately equal to FE, because when the object is closer to the focus, greater is going to be the magnification that is produced. Because when the image is coming, when the object is coming to focus, it is producing a highly enlarged image at infinity. So when it is close to focus, we can say that will produce a highly magnified image, and the adjustment is done in such a way that the final image is formed at the least distance of distinct vision. So here, if you observe, this angle is alpha and this angle is beta. Okay, and the magnification produced due to the telescope, when image is formed at least distance of distinct vision, is beta by alpha. So beta is tan beta divided by tan alpha. So what is tan beta, guys? So tan beta is so what is tan beta? See, so tan beta is equal to A dash B dash divided by A dash C. Sorry, A dash C dash. What is tan alpha? Tan alpha is equal to A dash B dash divided by A dash C. So tan beta by tan alpha will be equal to A dash C divided by A dash C dash. But what is A dash C?
D.
A dash C, ma. A dash C is this distance, no? So A dash C will be F naught. Okay. So A dash C is F naught. And what is C dash A dash? C dash A dash is approximately UV, but UV is approximately taken to be FA only. So if I take this distance to be UE and this distance to be V naught, then tan beta by tan alpha is equal to A dash C. A dash C is how much? A dash C is approximated to F naught divided by A dash C dash. A dash C dash is UE. Okay. Now let this be 1. So the magnification produced when the image is formed at least distance of distinct vision is F naught divided by UE. Similarly, for I lens, you will apply the lens formula 1 by VE minus 1 by UE is equal to 1 by FE. Okay. So you need the value of 1 by UE. So 1 by UE will be equal to 1 by VE minus 1 by FE. So what will be the formula for MD? MD will be equal to F naught into 1 by UE. 1 by UE is minus 1 by VE minus 1 divided by FE. So if I take FE outside, F naught divided by FE into 1 minus FE divided by VE is what is going to be the magnification produced due to this lens. Right? F naught divided by FE into 1 minus FE divided by VE with the minus sign outside. Because I'm taking this 1 by FE outside with the minus sign. So minus F naught divided by FE into 1 minus FE divided by VE. So minus F naught divided by FE, I'm not disturbing. 1 minus FE divided by, where is the final image formed? The final image is formed at minus D. So you will get the answer as minus F naught divided by FE into 1 plus FE divided by D. Please write it down.
So
This
could
is
you show
what.
the diagram for a minute, sir?
Sure, sure. Did you understand why V naught I wrote it as F naught? Because 1 by V naught minus 1 by U naught is equal to 1 by F naught. Where is the object placed with respect to objective?
The left of the objective, sir.
Left is okay. Where is the image placed? Sorry, object placed.
At infinity, sir.
When you put infinity here, this becomes 0, which implies
Yes.
V naught will be equal to F naught. That is why I wrote A dash C as F naught. Okay. Done?
One minute.
Right. Rohan, let me know once you're done.
Completed, sir. But could you just show the diagram on final tab? Okay, sir. Done, sir.
Done? Okay. So last part is very easy. It's called as a normal adjustment. That is when the final image is formed at infinity. So logic is very simple. So image due to the objective is formed at F naught, and the eyepiece should also coincide at the same point, so that the object distance with respect to eyepiece, if it is Fe, then the final image is formed at infinity. Right? So this is the simplest derivation you would have seen. Observe. So if I take this as alpha, what is tan alpha, guys? So what is tan alpha? Height of this object divided by F naught. What is tan beta? Height of the same object divided by Fe. So what is the m infinity? Tan beta by tan alpha. So it is going to be Fe divided by F naught, and just put a minus sign here because the final image formed with respect to the initial position of the object is inverted. That's it.
So M infinity is tan beta by tan alpha, right?
Tan beta is how much? H divided by Fe.
So it should be
I
F
wrote
naught by
another. So
Fe, right, sir?
F naught by Fe. Sorry. It should be F naught divided by Fe. The minus. So I hope you understood what that minus sign means. Minus sign indicates that the final image is inverted. That's it. Okay. So I'll do one problem. With that, this chapter is over, guys, by the way. So it is the end of chapter 9, right? So once I send this worksheet, you guys work on the problems, and if there are any doubts, you can reach out to me. But let's do one simple problem. If you take the objective of a telescope, it is a convex lens of focal length 100 centimeter. Its eyepiece is also convex lens, focal length, let's say 5 centimeter. Return the magnifying power of the telescope in normal adjustment. So M infinity is equal to F naught divided by Fe. F naught is how much? 100 divided by 5. It is 20. That's it. Right. I hope things are clear. Right. Any other doubt from today's class?
No, sir.
So now it is your time to revise it. So what I'll do is I'll give you 2 weeks time to prepare this chapter. So after 2 weeks, there'll be a test. There'll be a test according to the new board pattern. Okay. So it is going to be for 35 marks and 2 hours. So keep preparing. After I'll be sending a schedule on when the test will be. Is it clear? So from Monday, I'll start the next chapter, that is wave optics. So wave optics will exactly take 4 to 5 classes. That's it. After that, all other chapters you can take each chapter one class or 2 classes. Okay, 11, 12, 13, 14. So maximum will be done in 13 more classes. That is in less than a month from now, if you calculate. Okay. So that's it from my side for today, guys. There are no doubts, we can wind up.
So can I send this PDF also?
Yeah, I'll do that.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.